Okay, so question number 10 is to determine if carbon tetrafluoride is polar. Okay, so first let's draw out the Lewis structure of carbon tetrafluoride to see the type of shape the molecule will have. So when we write out the Lewis structure, we first need to find the total number of valence electrons. So carbon has 4, and a fluorine atom contains 7. And since there are 4 fluorine atoms, we multiply this by 4, and we get a total of 32 valence electrons. So carbon is less electronegative than fluorine, so it will be our central atom. And I'm just going to draw all the fluorines singly bonded to carbon, and I'll show all of their lone pairs. Okay, so we have all of the lone pairs drawn in, and if we count out all the electrons that I've drawn so far, each bond containing 2 electrons, then you'll see that we have reached our 32 electron count, and all of our atoms have a full octet, so we know that we have the correct Lewis structure. So now let's find out whether or not this molecule is polar. So the first thing we like to do is determine whether or not the carbon-fluorine bond is polar or nonpolar. So when we have a polar bond, then this is when the electronegativity difference is greater than 0.4 and less than around 1.69. And when we have a nonpolar bond, this is when our electronegativity value I'll just draw it. Is less than or equal to 0.4. Okay, so now that we know what constitutes for a polar bond and a nonpolar bond, let's find the electronegativity difference between carbon and fluorine. So if we look up their values or their electronegativity values, you'll see that carbon has an electronegativity value of 2.5 and fluorine's is 4. So this is equal to 1.5. So this means that the bond is polar. And that also means that since fluorine is much more electronegative than the carbon, then this means dipole moments will form and point in the direction of our fluorine atoms. But if we look at the actual shape of the molecule, you'll notice that the molecule is symmetrical and that all of the dipole moments cancel each other out. So we have a net dipole moment is equal to 0. So therefore, we can say that the CF4 molecule is actually nonpolar. So even though a carbon and fluorine bond is polar, since all of those dipole moments cancel each other out in the molecule, since the molecule is symmetrical, then it has a net dipole moment equal to 0, making the molecule nonpolar. If carbon were to have like a lone pair, causing it to be like bent in any way, then only then would we have a polar molecule. But since carbon has no lone pairs to affect the structure, then it is symmetrical. And the junior tutor said that the polarity of a molecular compound may be determined by looking at its Lewis structure. Compounds with symmetric structures are nonpolar because even if a dipole moment exists between two bonded atoms, these will cancel out. Compounds with asymmetry in their structures are polar because a net dipole moment exists. The structure of carbon tetrafluoride is the following. It has a tetrahedral geometry, bond angles of 120 degrees all around. I think the bond angles are actually 109.5, so I'll just fix that in the comments. And the symmetry of the tetrahedral shape cancels out dipole moments in all the carbon-fluorine bonds, resulting in a net dipole moment of 0. Therefore, the molecule is polar. Okay, so this solution is correct. Then I'll just put in in brackets with tetrahedral geometry. Bond angles are around 109.5 degrees. So the solution is correct.